Good afternoon, cadets. We already have studied the slope and deflection by double integration method. We completed all the 6 cases by double integration method. Now we'll start the new method, that is Macaulays method. Okay. So Macaulay is the name of the scientist or inventor of this method. By Macaulay's method, now we'll find the maximum slope and deflection for the case of simply supported. So this is the case written here: simply supported beam with point load W at the center. Okay, so we have to find the maximum slope and deflection for the simply supported beam which is carrying W at the center. So this is drawn here. This is simply supported beam AB of the length L. Okay, C is the center of the beam. It carries W at the center. L by 2 is AC. Next L by 2 is CB. Okay, we know whenever load is acting at the center, the reaction is half. So reaction value at the A is W by 2, reaction at the B is also W by 4. Once we get the reaction, we can write the equation for bending moment. Now the difference is to be noted. Before going to that, we'll write the known conditions. What are known conditions? We already know it. At the simply supported end A, x is 0 here because x has been started from here. X is 0, y is 0. And when x is increased to L, at B, y is again 0. So y at both ends is 0. So y is 0 at x is equal to 0. At x is equal to L also, y is 0. These are known conditions. Okay. Now, there are some rules for this. What is the first rule? Always take the left end as origin. Means the bending moment equations will be written from the left end. It means the value of the x is always been taken from the end A. So x will start from the left end. So x is always 0 at the left. Okay. So here the equations will be written separately for AC and CB. Now already we know the values of the slope and deflection by double integration method. Same values are going to come here also. Only difference is in the method of solving. Okay. The slope ka value at the end B and A is already known to us. That is WL square by 16 EI, which already we have found. Same value will come here. Same value of deflection will also come here, which was WL cube upon 48 EI. Okay. Now for the span AC, the first step is for the span AC, take the section X. So this is the section X taken at the distance X from A. So the equation for bending moment for AC will be W by 2 into X. And what is another sign convention here is left clockwise moment. This is the left and clockwise. Left clockwise moment is always taken negative. That's why minus sign is taken. Okay. So this is simply W by 2 into X. Minus sign is because of left clockwise moment. Now we have to write the equation for CB, next span. It means in between C and B we have to take a section. So this section X is now taken in between C and B. Okay, and it is again from the left end. So this is now become your X. So X is now changed. Okay, so if you write the equation on the left for this span, so pause for the CB, if you have to write bending moment at the section X is mx, which is nothing but W by 2 into X. Okay, same is written here, minus W by 2 into X, and this is opposite, that's why it is plus, and the moment of this is W into this distance. How much will be this distance? This total is X, this is L by 2, so this will become X minus L by 2. You can check it, X minus L by 2. So same is written here, W into X minus L by 2. Okay. So this is for span AC if you write separately. This is for span CB if you write separately. Now if I have to write the bending moment equation for whole span, that is for AC plus CB, that can be written like this. Bending moment for all section of the beam will be EI d square y by dx square is equal to, same is written, minus W by 2 into X. This is for AC. Dotted line which is splitting between AC and CB, this dotted line will be shown here, plus the remaining part is this, is written here for CB. So for AC this is the equation, plus CB this is the equation. It means it becomes the whole expression for bending moment if we have to find between A and B, that is X to L. So why it is splitted? What does it mean? So if we have to find the value up to AC, means from A to C, it means from x is equal to 0 to L by 2, the equation will be applicable only up to dotted line. Got it? If you have to find beyond C, so from L by 2 to L for CB, then you have to apply for the, you have to put the value for the whole expression. That is the difference. इसका मतलब क्या है? अगर आपको वैल्यू A और C के बीच फाइंड करना है, मतलब 0 से L by 2 के बीच में फाइंड करना है, तो वैल्यूज आपको सिर्फ डॉटेड लाइन तक ही फाइंड करना है, डॉटेड लाइन तक ही रखना है. पर अगर आपको वैल्यू C और B के बीच में फाइंड करना है, which is beyond C, beyond L by 2, in that case the value of x is put for the whole expression so that you can get the value for the whole expression. So that is the significance of the dotted line. Okay, now next is, again we will do the integration. Integrate this equation, so ei dy by dx minus w by 2, as written minus w by 2, integration of x is x square by 2. Now the constant of integration c1 is added plus c1, then same dotted line is shown here, the same dotted line, and the same remaining integration is written. W is constant. Now make the note of this. While making the integration of this, take this as a whole function of x. It means it is a x raised to n. So take the integration of x minus L by 2 as x minus L by 2 whole square by 2, because integration of x raised to n is what? X raised to n plus 1 upon n plus 1. So this is the integration that is to be noted. What is the difference? Equation should be written separately for AC and CB. Dotted line is showing the difference. Whenever you have to find the value of x for AC, up to dotted line you have to put. When you have to find for CB, for the whole expression we can. And whenever we have to do the integration of the terms will be done as whole, not at separate. So the whole term is integrated here. This becomes your equation number 2. Okay, so just take the look at this, understand the difference, and then in the next video we'll go for finding slope and deflection.